Okay, Assalamualaikum and good morning everyone.
Okay, salam sir.
Waalaikumsalam.
Walaikum salam, sir.
Alright, so okay. Okay, so let's start our class. Alright, so today we are going to learn on the next subtopic of lecture number 2, which is about the transfer function of translational mechanical system. So yesterday, we should discuss tutorial. Tak apalah, nantilah. Okay, so yesterday we have learned about um, the method on finding transfer function using Laplace transform. Okay, maybe we should discuss the tutorial first. Okay. Okay, so yesterday we have learned about chapter 2A on finding the transfer function, and I gave to you several tutorials, but we will discuss some of them. Okay. Okay, so we will discuss tutorial 2A. Okay, so in this tutorial, given the ODE of a system with initial conditions below y double prime minus 5y prime plus 6y equals 1. So the initial conditions are 0. So using Laplace transform and partial fraction expansion, determine yt. Okay, so first step you need to do is you need to use Laplace transform to convert the differential equation into an algebraic equation. Okay, so first step is using Laplace transform. So you get s squared ys minus 5s ys plus 6ys equals 1 over s. Betul ke? Lupa dah. Okay. Okay, so after you get in terms of frequency response, then you need to rearrange. You need to rearrange to get ys equals something, equals the transfer function. So ys times s squared minus 5s plus 6 equals 1 over s. Then ys equals okay. And then what you need to do next is you need to factorize the fraction before you can do partial fraction expansion. So from here you get s times s minus 3, s minus 2. Okay, you need to factorize. Then from here you can use partial fraction expansion. So it equals a over s plus B over S minus 3 plus C over S minus 2. Okay, then you need to find A, B, and C. So you need to do the methods that are given in the slides, or you can use your own method. Okay, so I prefer the other method, which is you equate the numerator. Okay, so 1 time equals A times S minus 3 S minus 2 plus B S S minus 2 plus C S S minus 3. Okay, from here, then assume S equals 0. Then you get 1 equals A times minus 3 times minus 2. So A equals 1 over 6. And then assume S equals 2. No. S equals 3. Then you get 1 equals B times 3 times 1. So B equals 1 over 3. And lastly, assume S equals 2. You get 1 equals C times 2 times minus 1. So you get C equals minus half. Then substitute back into YS. Okay, so you get your YS. Then you apply inverse Laplace transform to get YT. So use inverse Laplace transform. So you get YT equals 1 over 6 plus 1 over 3 E power of 3t minus half E 2t. Okay, so this is how you do it. Okay. Okay, any question before we go to the next tutorial?
No, sir.
Okay, senang kan? Boleh dapat A. Okay, we go to the next tutorial 2B will be the same thing. Okay, so you can try by yourself. Okay, let's go to tutorial 2C. So tutorial 2C, consider a system described by the differential equation y double dot plus 7y dot plus 10y equals r dot plus 3r. Find the system response y to an input rt equals e minus t ut, assuming 0 initial condition. Okay, so the first step you need to do is you convert this into frequency response. So use Laplace transform. So R equals e power of minus t. You get Rs equals 1 over s plus 1. Okay, then you use Laplace transform on the differential equation. So from the differential equation, you will get ys s squared plus 7s ys plus 10 ys equals srs plus 3rs. Okay, then you need to rearrange the equation to get in terms of y. So ys equals s plus 3 rs divided by s squared plus 7s plus 10. Then you substitute rs into the equation here. So you will get s plus 3 divided by s squared plus 7s plus 10 times s plus 1. Then you need to use a partial fraction, but first you need to factorize. You need to factorize this section here. So you get s plus 5, s plus 2, s plus 1. Then you use partial fraction. So here you get a over s plus 1 plus b over s plus 2 plus c over s plus 5. Then you equate the numerator. Okay. Then you need to find a, b, and c. So assume s equals minus 1. You get 2 equals a times 1 times 4. So a equals half. Assume s equals minus 2. So you get 1 equals b minus 1, 3. So b equals minus 1 over 3. And lastly, assume s equals minus 5. So you get minus 2 equals c times minus 4 times minus 3. So c equals 1 over 6. Okay, substitute back into the equation. So you get ys equals half s plus 1 minus 1/3 over s plus 2 plus 1/6 s plus 5. Then you use inverse Laplace transform. So you get yt equals 1 over 2 e power of minus t minus 1 over 3 e power of minus 2t plus 1/6 e minus 5t. Okay. So this is the final answer. Okay, any question?
Aduh.
Saya boleh scroll ke bawah sikit tak nak tengok yang tu. Thank you sir.
Alright. Okay. Okay, so if you don't have any question, we continue with our lecture. All right, so we continue with lecture 2D, okay? Okay, so 2D, lecture 2D will be about finding the transfer function of translational mechanical system. So translational mechanical system means a system that is either moving forward or backward or moving up and down, okay? It doesn't involve any rotation yet in this topic, okay? So that's translational. So in this topic, students will be able to create transfer function for translational mechanical system for single degree of freedom and multiple degree of freedom system. Okay, so there are two types of systems, single degree and multiple degree. Okay, so before that, let's look at an example of a translational mechanical system. So this is an example given in the book by Norman Nice. So I'm not sure whether this system is available in Malaysia, but this system basically is a plate dispenser. Whenever you pick up the plate, the top plate, then the load on this spring here will reduce over time, and the spring will push the plate upwards. So whenever you take the top plates, then new plates will become available. So in this thing, it's basically a translational mechanical system because it only moves either upwards or downwards. So how to model the system? So how can we control YT? Basically, we can assume that this piston is something with a mass, and then we want to find the position or the displacement of this mass, and then the plates is represented by the force which push the box downward, and on the box there is a spring, and also we can also put a damper. So generally there are two things, damper and also spring. So before we go into further about deriving that system, let's look at some theory, some basic understanding of the translational mechanical system. So here in the slide shows an example of 1 degree of freedom system. So usually for 1 degree of freedom system, you have a box with a mass M. So we want to find the displacement or position of this box. So we label the displacement as xt, function of time. And usually on the box, we have a force, F, which either apply forward or backward. And then you have the spring with constant K, which is attached to the box and to a wall. And you also have a damper with constant FV1, also attached to the wall and to the box. And you have a friction between the box and the floor. So the coefficient of the friction is FV2. So here we would like to model the motion of the mass M. We want to model the position X of the mass M. So firstly, what is the system? What is system degree of freedom? So what is degree of freedom? So basically degree of freedom is how many unconstrained motion that you can determine from this system. So in this system, only the position of the box M that is unconstrained, meaning that the box M can either move forward or backward. There is no other things that that can move in a different direction. So here, when the box M moves, then everything else will follow. So there is only one degree of freedom in this system. So later on, we will see an example of multiple degree of freedom, but here only the position of the box M that can be measured. So before we can model the system, generally there are 4 modeling steps. So the first step is you need to decide on the input and the output of the system. So here in this system, the output that we want is the position X. And the input for this system is the force. Because we apply the force, we give the force to the system, which acts as the input. And then the output or the results is the position of the box. And after we decide the input and output, then we need to list all the forces acting on the mass. So here we have the force F, we have the force by the spring, we have the force by the damper, and the force by the friction. So after we decide the force, we need to draw the free body diagram of the system. Next is we need to convert the equation. After you draw the free body diagram, you will write an equation of motion. And then from there, you need to convert the equation from time domain to frequency domain using Laplace transform. And lastly, you need to rearrange the equation. After you convert into frequency domain, you need to rearrange them to get the transfer function, which is you need to determine the output over the input. Okay, so there are 4 general steps you need to follow, okay? Okay, so let's look at how to determine the transfer function for this system. Okay, step 1, we need to decide the input and output. So the input is the force, F. So we give the force on the box. And then the input is the mass position, which is X. Or sometimes you can determine the velocity of the box. So you need to differentiate the position. Also, you can also determine the acceleration of the box. So you need to differentiate twice. And then after you determine the input and output, then you need to draw the free body diagram by listing all the forces. So here is the trickiest part. So here, what you need to look at are the forces on the box. So here you have the force input F. So the force F will act forward, okay? will act according to the direction of the given force here. So while the box moves forward due to the force F, then the spring, the damper, and the friction will produce forces such that it will resist the motion of the box. So when the box moves forward, then the forces by the spring, the damper, and the friction will act backward because it tries to resist the motion of the box. So because of that, the force by spring acts backward. The force by damper also backward. The force by friction also backward. Then lastly, you need to include the inertia of the box. So the inertia also, the force acts backward. So there are 5 forces, including the input force. Okay, so if you have a mass, so here you have the mass M here, then you must have the inertia, the inertial force. Sometimes you don't have mass for the box, then you don't have the inertial force. Okay, so this is how you convert the forces from spring, damper, and inertia. So for spring, if you have a spring constant K, then the force will be K times position X. If you have damper, FV, then the force will be FV times the differentiation of X, or FV times X dot. So damper also the same as friction. So if you have friction, then you need to multiply friction with X dot, or the position or the velocity of the position. Okay. Then if you have mass M, then the force will be M times X double dot. Okay, so you need to remember, for a spring, the force is K times X. For damper or friction, it's FV times X dot. And for mass, it's M times X double dot. Okay, so this is when you convert into frequency domain. Okay. So after you draw the free body diagram, then you can convert all the forces into frequency domain. So this is in frequency and this is in time. So after you convert into frequency domain, then you can write the equation of motion. So basically, all the forces backward equals forces forward. So ms squared times x plus fv1 sx plus fv2 sx plus kx equals f. Okay, so force backward equals force forward. Okay, then after you write the equation of motion, then you can separate the output and input, meaning that you factorize x and then rearrange the equation. Okay, factorize x. So after you factorize x, then you can then you can find the transfer function. So here, if you want to find the position, then you find the x over f, the transfer function x over f. Then rearrange, you get this as the transfer function. Sometimes you want to find the velocity as the output. So velocity x dot equals s times xs in frequency. So you just calculate xs times s over fs, then you get a different transfer function. And lastly, sometimes you can also find using acceleration. So if you want acceleration, then it becomes s squared times x. Okay, so it's a matter of how you calculate je. Okay. Okay, ni bukan formula, okay, ni nanti kena kira sendiri. Okay, so that's basically the steps for 1 degree of freedom system. Okay, so I give you an exercise. Maybe we can try it now. Okay, so find the transfer function x over f. So this is a system, 1 degree of freedom system, because you have only one position of the mass. But this time, the system is vertical instead of horizontal. Okay, so the first step you need to do is you need to determine the input. So the input is the force F, and the output is the displacement of the box X. Okay, so after you decide on the input and output, then you can draw the free body diagram. Okay, free body diagram. So firstly, you need to draw the box. Okay, so the force F acts downward. And the forces by spring K and damper B will try to resist the motion of the box. So now the box, the motion is downward. So the force by damper and spring will be upward, such that it tries to resist the motion of the box. So you have damper B x dot. Okay, so for damper, always times with velocity. And then you have the spring, K times X. So for spring, it's always times the displacement. And lastly, because the box has inertia, so you must have an inertial force, M times X double dot. Then from the free body diagram, you can write the equation of motion. So equation of motion, mx. So equation of motion will be the forces acting upward equals forces acting downward. So mx double dot plus bx dot plus kx equals f. And then you use Laplace transform. to write the equation of motion in terms of frequency. So you get ms squared plus bs plus k times x equals f. Then step number 4 is to find the transfer function. So rearrange the equation to find the transfer function as the question asks. Okay. So here the question asks you to find x over f. So rearrange x s over f. So you get 1 over ms squared plus bs plus k. Okay, so that's the procedure, okay, the method. Okay, any question before we go into multiple degree of freedom?
Tadi.
Okay, so for example, exercise 1 here, usually we ignore the gravity, the effect of gravity. Kenapa ignore? Ada explain dalam buku hari tu, tapi lupa dah macam mana dia explain. But basically we ignore the gravity unless the question said do not ignore gravity, for example. Okay, so that's why there is no gravity here. Okay, so we proceed. Okay, we go back to our case study introduced at the beginning of this lecture, which is about the restaurant plate dispenser. Okay, so from this system given to you, then you can derive the transfer function. So first you need to draw the free body diagram. First you need to identify the input and output, which is the input is the force, output is the position of the box. Then you can draw the free body diagram. Then from the free body diagram, you can write the equation of motion, use Laplace transform to get in terms of frequency. Then from the equation of motion in frequency domain, you can rearrange to get the transfer function. So here the transfer function you need to find is ys over fs equals this. Sometimes the question will give you values for each of the constant. Here the force given is 2 Newton. Then you need to convert into frequency. So in frequency, 2 newtons equals 2 over s. Then substitute everything into the equation, into the transfer function. So substitute, you get a fraction here. So you use partial fraction. Okay, so that's why you learned about partial fraction yesterday. So this is how it used, okay, how it is used. So from the fraction, you use partial fraction. You determine the constant A, B, and C. And then you get ys in terms of fraction. And then from ys, you use inverse Laplace transform to get an equation here. Okay, so from this time domain equation, we can plot a graph, for example. So example given here, when you plot the graph of yt, it shows that the position of the box starts at 0, and then suddenly the position drops at -1. But it takes some time before the box to stop at -1. So ideally, in this subject, in control system, what you want is basically you want to control uh, the time taken for the box to reach this steady value. So here, the time taken is about 6 seconds. But sometimes you want the system to be faster. Whenever you take the plate, then new plate will come out quickly without taking 6 seconds. Okay, for the plate to come out. So in control system, in this subject, you want to reduce this time. Maybe you want the system to be as sharp as possible, something like this. But in real life, there is no such system, because usually you will get a vibration. Okay, if you have a system that quickly like the plate dispenser, whenever you take the top plate, then the system will quickly shows up the new plate, then the system might vibrate. So what happens is that the system will vibrate before it reach a steady state. So this vibration uh, uh, is is the thing that we don't want, basically, because when it vibrates, then it can cause damage to the system. Like for example, the plate dispenser, whenever it vibrates, then macam gempa bumi lah. Bila bergegar, maybe the plate can damage, can broken, can break. So we don't want the system to vibrate. But if you don't want the system to vibrate, then you need to take some time for it to reach steady state value. So if you don't want the system to vibrate, then the system will perform very slowly. So there is a pros and cons. If you want it to be faster, then the system will vibrate. If you don't want the system to vibrate, then the system must perform slowly. Itulah dia. Itulah dia yang kita akan belajar. Tak ada isu pun sebenarnya benda ni, saja nak bagi korang susah. Okay, so that's an example from a restaurant plate dispenser. Okay, so we covered the first subtopic, which is single degree of freedom. Okay, so let's look at an example of 2 degree of freedom. Okay, so here in this example, you have 2 masses or 2 boxes. Box M1 with position X1 and box M2 with position X2. So here, why it's 2 degree of freedom? Because basically, if you hold the box M1, for example, if you hold box M1, you fix box M1, then M1 can move independent of M2. M1 can move either backward or forward. Now you fix box M1. If you fix box M1, then box M2 can move either backward or forward, independent of either M1 stops or not. So here, there are 2 different motions. First is the motion by M1, independent of M2. And second one is the motion of M2, independent of motion M1. So because of this system is called 2 degree of freedom. Okay, so the same modeling steps you will require to use. So first you need to decide the input and output. Then you need to list the forces acting on each of the mass. So there are 2 degree free body diagram here because there are 2 degree of freedom. Then you need to convert the forces into frequency domain. And lastly, you need to isolate output from input. Okay, so let's look at how to do this. Okay, so the first step is you need to determine the input. So the input is the force F here. And the output can be position X2. Or the position X1. Mana datang equation ni? Okay, ada missing slide. Okay, so after you determine the input and output, then you need to draw the free body diagram for each of the mass. Okay, let's draw free body diagram for mass M1. Okay, so on M1, you have the motion X1 going forward. Okay, so when when M1 goes forward, then the forces by the spring attached to M1 will try to resist the motion. So the first force is K1 here. So force from K1 is acting backward. And then the damper FV1 also, the force acting backward. And here we have the spring K2. So K2 is attached to M1. So because K2 is attached to M1, then the force by K2 on M1 will act backward. So K2 X1. And don't forget the inertia of M1. So you have the inertia M1 X1 double dot. Okay. But the spring K2 is also attached to M2, meaning that there's a force from M2 on M1 by the spring. So the force from K2 from M2 by the spring K2 will act forward. Okay, so K2 X2. So from this free body diagram, you can write the equation of motion. So this is the equation of motion. Okay, now we look at the second mass, okay, which is mass M2. Okay, so on the mass M2, you have a force, the input force F, and you have the spring K2 attached to M2. So the force by spring K2 will act for backward. Okay, so the spring K2 attached on M2, the force will resist the motion of M2. So M2 is now moving forward, but the force will resist the motion. So that's why it's acting backward. And the spring K2 is also attached with M1. So because of that, there's a force from M1 on M2. So the force is acting forward. So K2 X1. And don't forget the inertia, M2 X2 double dot. So from the second free body diagram, this is the equation of motion. Okay, so from the equation of motion, then you can rearrange them in matrix form. Ada soalan ke tu? Okay, so if you have any question, just ask, okay? Because I cannot see our Google chat. Okay, so after you have the equation of motion, then you need to rearrange the equation of motion in matrix form. So the matrix form, you have to arrange such that this is the position. Okay, so you need to rearrange. Basically, you need to separate x1 and separate x2. Separate them and then write in matrix form. Okay, so this is the position, this is the force, and this is the coefficient. Okay, arrange them in matrix form. So after you arrange in matrix form, then let's say if you want to find x1, then you use Cramer's rule. So for example, if you want to find x1, if you want to use Cramer's rule, then what you do is, what you need to do is you substitute the force into the first column here and find the determinant. Okay, so this is the determinant. Okay, determinant of matrix yang AD tolak BC tu. So you find the determinant by substituting the force column into the first column divided by the determinant of the coefficient matrix here. Okay, so that's how you find x1. Okay, if you want to find x2, then you substitute the force column here into the second column, find the determinant, divided by the determinant of the coefficient matrix. Okay, then you can simplify the determinant. Okay, you can simplify determinant. You get AD tolak BC. Okay, any question?
Banyak sangat tu.
Apa yang banyak?
Tu.
Banyak apa?
So
Jangan
Ya.
kalau ada value S tu kita masukkan terus dalam untuk kira determinant tu ke?
Okay. Okay, untuk S. Okay, untuk S ni Apa benda lah S ni? Anggaplah untuk sekarang ni S ni adalah sesuatu sesuatu yang kita nak cari. Macam X lah, okay? Macam quadratic equation, tiba-tiba ada X. Kenapa nak cari X? So S is something like that. So S is something that you will find later. Later in lecture 3, lecture 4, lecture 5, you will learn about S. But for now, you need to remember that only the coefficient like M, K, FV, K1, K2, M1, M2, all of this, only this have values. But S, we don't have the value for S for now. But later, in next chapters, we will learn more about S. So your transfer function later on will be in terms of S. For example, if you get X1, maybe the final answer will be like 5S plus 1 over 6S squared plus 3S plus 2. So the answer will be in terms of S. So you don't need to substitute anything on S. You just anggap S tu sebagai sesuatu constant, like a constant, like a variable. We don't substitute anything on S, okay? So make sure you take the value, take S as it is, okay?
So kalau macam situasi ni kita biarkan S tu jadi kuasa 4 lah kan. Lepas
Yes, betul.
Okay.
Pandai. Pandai pun. Okay, so dia akan jadi S power of 4 plus S power of 3 plus S power of 2 and so on. Later on, we will learn about S, okay? Maybe after midterm. Okay, any more question? Sebab dah nak habis dah. Nanti pening kepala banyak sangat.
Saya.
Yeah.
Masa kita nak convert dia punya determinant ni, kita kena kalau diberi value, kita masuk value je lah.
Yes. Usually sebelum kalau diberi value, let's say you are given value for M1, FV1 and so on. Before you calculate the determinant, you substitute the value first to make the equation simpler, okay? Nampak cantik sikit. And then after that you determine the determinant.
Okay.
Okay, next. Tak nak layan dah macam tu. Okay, any question? Okay, so if you don't have any question, then you can try this exercise. Try this exercise and tutorial 3A. Jap. Okay, you can try this exercise. So here the question asks you to find the transfer function x2 over f. So when the question asks you to find x2, so you don't need to calculate x1, meaning that, for example, like in previous slide here, it calculates for both x1 and x2. But the question asks you to find x2 only, so you only calculate x2. So you don't need to trouble yourself to calculate x1. Okay, so that's for exercise, okay? But this system is 2 degree of freedom. So you will require to use matrix form.
Fokus satu lah tau.
Yeah, dia still kena 2 degree of freedom, tapi masa nak cari Cramer's rule tu, cari X2 je, tak payah cari X1.
Oh, okay.
Faham. Tak apa, try dulu. Okay, so this is tutorial 3A. So same thing, but in this tutorial, dia lain sikit, dia nak X1 over X2. So in this case, you need to find both X1 and X2, and then you divide both of them. X1 divided by X2. Okay, so that's for exercise 3A. So same thing, but in this tutorial, dia lain sikit, dia nak X1 over X2. So in this case, you need to find both X1 and X2, and then you divide both of them. X1 divided by X2. but this is also 2 degree of freedom. Okay, tutorial 3B. Okay, we will go into 3 degree of freedom next week, but you can try first how to do 3 degree of freedom. Basically the same thing, but you have an additional degree of freedom, and later on your matrix will be 3 by 3 matrix instead of 2 by 2 matrix. So when you have 3 by 3 matrix, then the difficult part is to determine the determinant of 3 by 3 matrix. Dah lupa dah macam nak buat. Masa matrix dulu belajar, masa poli ke, masa bila-bila. Okay. Try first tutorial 3B. Okay, so next week we'll go into this example. And I think next week, Wednesday, I want to do quiz number 1.
Okay.
So next week, Wednesday, I will do quiz number 1. We will cover lecture 1, lecture 2, and this topic, okay? So there will be 2 questions. I think macam real exam lah. 1 question 45 minutes. So 2 question 1.5 hour. Hantar masa kelas, okay? So just study a bit. Soalan dia tak susah pun, macam tutorial je. Okay, so we will discuss the tutorial on Tuesday, and we will continue on the topic, okay? Okay, so any question before we end this lecture?
No, sir.
No, pandai tiba. Okay, so if you have no question, then that's it for today's lecture. If you have any question, you can just direct to me, okay, through WhatsApp.
Attendance, sir. Attendance.
Attendance halalan toibah.
Allah selalu. Alright, thank you, doctor.
Okay.
Thank you, sir.
All right.
Thank you, sir.
So that's all.
Thank you, sir.
Thank you.